Welcome back. In the first segment, we talked about why data generation was so central to artificial intelligence. And now we're going to talk a little bit about how we can actually do that and introduce the concept of physics-based data generation. So first of all, when it comes to data generation, there are a lot of different tools that people use. Typically, they're computer graphics tools, or they rely on other augmentation elements that are part of TensorFlow or PyTorch. We really encourage you to use a purpose-built synthetic data generation tool. And let me share a little bit about why. First of all, none of those tools really carry out physics-based simulations. Physics-based simulations give us an opportunity to achieve a very high level of realism, which is great for our machine vision training. But it's not the only reason that physics-based is so important. In fact, there are other tools that can give us apparently realistic images, such as generative adversarial networks. But with the physics-based engines, we get root cause traceability, so we really can understand what is driving the elements of that scene, which is not the case when we use other generative methods. From that root cause traceability, we can really understand our ground truth and what is in the image, which allows us to achieve explainable outcomes in our data generation, ultimately getting us towards provable artificial intelligence. And I'd just like to give one example of that. This is an example of a simulated radar image. And in these images, we actually see some of the aspects that are important for the radar sensor. You see hotspots from the reflections on points of the plane. We can see that actually half the plane seems to be invisible. Of course, it's not invisible, it's just the radar signal didn't get to that side. And shadows operate completely differently than we would anticipate they would from a visible image. Now, all of those things are things that we get out of simulating the physics of a radar, but that you wouldn't get if you were just trying to use a generative adversarial network to create the same image based on an optical ground truth.